Hello, this quick video is just going to show you how to do partial fraction questions. I'm going to then apply it to how to integrate using partial fractions. Okay, so let me just write that down actually to start with. That would be a good start. Okay, so there's my original thing. The way we're going to split this up, if they don't tell you, the way you're going to work it out is by looking at the orders here. So let me just write it first, then explain. So you'll notice you get A going with one of the linears, B going with the other linear part there. Okay. If you can imagine at the bottom, the highest order would be x squared, since if you multiplied these two brackets out, the highest order would be 2. And for this linear, the highest order would be 1, since the power on that x is 1. So this is what you would end up with, okay? The first step I would always do is to multiply through. It's essentially by whatever is the denominator here. So these two linears. So you can think of that in this particular question as that, or just simply as the denominator. Okay. So if you to do that, you would end up with just x plus 4 here, since the denominator would have been multiplied by, and that would cancel on this side. Then a would be pairing up with just x plus 2, since the x plus 1 in the denominator will cancel, and you still are multiplying by that one as well. And the reverse for b, so this one will pair with the opposite, x plus 1. Okay, now you're at this stage. I tend to use substitution. Sorry, I didn't spell that right at all. Okay. Now, always look here. So essentially, if we can make these brackets a 0, then we can actually one by one find a and b by making a and b go to 0. So if I try and make a go to 0 first, okay, basically, I don't mean a actually going to 0. I mean, if I can make all of this term go to 0, then I can have a look at finding b first, for example. So if I make x negative 2, then this bracket becomes a 0, and anything times 0 gives me 0. So that deletes all of this. So first choice would be to let x equal negative 2. Okay, so if I put negative 2 here with the 4, that's going to give me 2 on this side. A is going to be here, but that's going to be negative 2 plus 2, which is a 0. I'll just write it for now. And then I have plus b. X is negative 2, so that's minus 2 add 1, which is minus 1. And so this all simplifies down to 2 equals negative b. Which then leads me to say that b is negative 2. Okay? So that's the first one. Now the second one, we now would like to make all of this go to 0. And so if I make x equal to negative 1, this bracket becomes 0, and then multiplying out gives all of that as 0. Okay? So negative 1. Let's start back here. We've got negative 1 plus 4, which gives me 3. I've got a. Here we've got negative 1 add 2, which just gives me 1. And then here we've got plus b minus 1 plus 1, which you can see that goes to 0. And so this just simplifies to 3 equals a, and therefore a is 3. Okay, now we have these, we can simply put these back here. Okay, so that's going to be 3 here and -2, but what we can do is just change that to a negative and put 2 there. Okay, and there we go. So imagine instead now they actually wanted you to try and integrate this thing here. Right, there we go. So if they wanted to integrate that there with respect to x, what you would actually do is do this first part here where you'd express them as partial fractions. So we already have our result here. So we've got 3 for the first one and then -2 for the second one. So we can just simply get that straight in. So it was 3 for the first one and then -2 for the second one. Then what we need to remember is our rules here. So when we integrate, this will go to a log natural. I will show you the rule for that. So you can think of it with this one. Because if I was to look here, I have x plus 1 at the bottom, 3 at the top. I should have put a dx in there, my bad. Okay. If I think about this, I've got a function of x at the bottom, which is x plus 1. If I differentiate that, I get 1, okay? So if I actually had this, okay, then this rule here would tell me, since the derivative of the function is exactly at the top, then I would get the log natural of the function you see at the bottom. As you can see, the f of x is here and here, okay? But since I don't see a 1 there and I see a 3 there instead, then it's just 3 times the amount, and so this one is 3 ln x plus 1. Okay? And so that's how we do it. So here we've got, coming down, we've got 3 ln x plus 1. And then for this one, since we've got -2 at the top, take the derivative at the bottom, it still gives you 1. We should see a 1, but we see a -2. So this is just -2 ln x plus 2 plus c. Now, we're not quite done here. We could do a little bit more. The numbers at the front of the ln's here, we could actually move up as powers. And when you subtract logs, it becomes division. So there's 2 things going on here. So let's think about those 2 things. So the first thing is if you have a ln x, that can interchange and become ln x to the a. And they can go back and forth. Second thing is, remember, if we have a subtraction of 2 logs here, this will give us ln a over b. So we can perform both of these. Okay. So first, let's do the number 1. So that's going to make it ln x plus 1 cubed. Take away ln x plus 2 squared. And secondly, we can then make that into a fraction. like that. Okay, so this here would be the final answer. Using all the laws of logs, basically. Thank you, I hope that helped.